There are some things that clearly count as science: biology, chemistry, and astrophysics, to name a few. And then there are some things that clearly don't count as science, like astrology, phrenology, and crystal healing. But what is the difference? Is there one? Things like astrology and phrenology are sometimes called pseudosciences. This means false science. That helps distinguish these kinds of things from history, literature, art, and other pursuits, which are legitimate academic disciplines but are not sciences. Pseudosciences seem like they might be scientific disciplines, and they claim the authority of science, but they don't meet the standards to count as true science. But what are those standards? What makes something count as science? It turns out that this is a challenging question to answer. Philosophers in the middle of the 20th century were concerned with attempting to demarcate science from pseudoscience by finding a set of criteria that all sciences meet and no pseudosciences. Demarcate means clearly distinguish or draw a clear line between two things. So this problem is often called the demarcation problem. One influential proposal for answering the demarcation problem is due to Karl Popper, who argued that what science does, that other disciplines, including pseudosciences, do not do, is hold itself up to the standard of falsifiability. His idea is that scientists are interested in attempting to prove their theories wrong. In Popper's view, that's the purpose of doing experiments or conducting scientific studies. Scientists are attempting to find results that falsify their theories by showing that they are incorrect. A good scientific theory is one that we have not yet falsified. Okay, so let's look at an example to see how this is supposed to work. Imagine your horoscope for today said that you would have a mysterious encounter with a stranger. However, you're homesick with the flu, so you don't see anyone at all. A proponent of astrology might attempt to explain this away by saying various things. For example, since you didn't leave the house, you didn't meet the conditions for the prediction to apply to you. Or they might say that you did have a mysterious encounter with a stranger, for example, that actor in the ad that you saw, but you just didn't realize it. Or they might note that the prediction actually said you may have a mysterious encounter anyway, so the fact that you didn't isn't evidence against the truth of the horoscope. Indeed, horoscopes are written in a way so that people reading them tend to see connections to their experiences, whatever those experiences turn out to be. Popper's falsifiability criterion says that for astrology to count as science, it would need to make clear predictions, and practitioners would need to actually go out of their way to attempt to test those predictions. And if those predictions don't happen, they would then need to abandon the theory. Because astrology makes only vague conditional predictions and attempts to explain away contrary evidence, it doesn't satisfy the falsifiability criterion, and therefore it's not scientific. The problem with the falsifiability view of science, though, is that it just isn't true of science in practice. A scientific theory is a complex web of interrelated hypotheses. We're confident in each of those to different degrees. So if we get experimental evidence that goes against the prediction of a theory, it's always possible to tweak the theory in small ways to account for that result. Sometimes it makes sense for scientists to do that. So the conditions for Popper's standard of falsifiability are almost never met in real-world science. A more flexible approach to defining what counts as science is to make a list of important features of science and then compare a project for how well it fits that list. Here's a list of 6 features. You can think of this as being like a checklist for when something counts as scientific. First, a scientific activity or project aims to generate knowledge. Human activities can have many different aims, creative or practical. But science's aim is to generate knowledge of our world. Some of the knowledge science aims to produce is practical, some is theoretical. Science has generated knowledge of human anatomy, effective medical treatments, how the universe changes over eons, monetary systems, and much, much more. Second, a scientific project seeks natural explanations of natural phenomena. We can call this naturalism. Natural phenomena are just objects, events, or processes that are sufficiently uniform for systematic study. So, for example, the solar system, economic downturns, and photosynthesis are all natural phenomena. What it means for science to seek natural explanations of such phenomena is just that it invokes features of the world, natural phenomena, when explaining occurrences in the world, other natural phenomena. Supernatural explanations are off limits in science. Third, a scientific project puts forward ideas that can be tested with empirical evidence. Let's call this empirical investigation. Scientists seek to test their ideas with experiments or other techniques for gathering empirical evidence. Ultimately, this is just a commitment to using one's senses to inform one's beliefs about the world. Fourth is evidentialism. A scientific project accepts ideas based on how well they are supported by evidence, and updates ideas based on available evidence. No hypothesis is accepted without sufficient evidence in its favor, and if new evidence comes to light, ideas will be updated accordingly. So, for example, human-caused climate change has been investigated by thousands of scientists over more than a century, and these investigations increased our certainty of global warming, its human causes, and refined our predictions of how climates will change in response. Fifth, a scientific project abandons any idea that has been thoroughly refuted. Let's call this openness to falsification. When astronomical evidence showed Einstein was right instead of Newton about gravity, scientists accepted Einstein's new theory, even though it fundamentally changed our understanding of space and time. This is like Popper's falsifiability criterion for demarcation. But notice that this doesn't mean that scientists should always be running around trying to disprove their best theories, and it doesn't prohibit adjusting ideas in light of new data instead of abandoning them. Another difference from Popper's falsifiability is that openness to falsification is only one element of what makes something count as scientific. And last but not least, a scientific project involves the broader scientific community. Scientific research is produced through the collaborative efforts of researchers embedded in the social and institutional structures of science. New research is informed by the results of others' previous research, including research about other related phenomena. And scientific research is supported by scientific institutions. Science is taught in universities, funded by scientific funding agencies, and so on. This checklist approach to defining science differs from Popper's answer to the demarcation question, because it's not just one single feature that all sciences have, and that no pseudosciences have. There's a lot of variety in what goes on in science. On the checklist view, scientific activities or projects can have each of these features in different ways and to varying degrees. Some pseudosciences may have some of these features as well, but no pseudoscience will have all of them. This gives us a more flexible way to determine which projects or activities qualify as scientific. In the 2010s, various prominent celebrities started wellness brands, offering products and advice subscriptions. Several of these took off, gained popularity, and raked in tons of money. This was about health. Science studies health. Were the recommendations of these brands scientific? No. The recommendations weren't based on scientific knowledge, but designed to make money and increase influence. Maybe the products and advice only related to natural phenomena, and maybe the health claims made could have been tested with evidence. But evidentialism was violated, since empirical evidence wasn't sought before recommendations were made. And if products were pulled, it was because of outcry against them rather than new empirical evidence coming to light. Finally, celebrity wellness brands didn't seek support from science's social and institutional structures by incorporating research findings or even seeking FDA approval. Nonetheless, the specter of a relationship to health advice that is evidence-based helped this pseudoscience seem legitimate. A checklist approach to defining science may not offer as clean a demarcation between pursuits that count as science and those that don't as one single rule would, since it does allow for some gray area. But it can reveal how pseudoscientific activities and ideas fall short of being science and thus don't deserve the respect that we grant science.